Okay, welcome. Today we're going to learn about maximum area. We've already looked at maximum revenue problems. Today we're going to switch it over to area problems. So go ahead and take your notes out and remember to pause the video at any point to get caught up and re-listen to certain concepts if you got stuck the first time and jot down any notes you may still have. Okay, let's begin. Our learning objective from this video is students will find the maximum area of any problem using quadratic problem solving techniques. So our action verb is to find. What are we finding? We're finding maximum area. How are we going to do it? Using quadratic problem solving techniques. So we're still working in our quadratics. So our first problem we're going to look at is, and I would like you to write this down, so go ahead and pause the video anytime and please copy it down. Okay, so the first problem we are going to look at is about a couple who wants to build a garden. So I'll go ahead and read it. A couple of homeowners want to build a garden up against the back of their house. To keep out their small dog Jenkins, they need to surround their garden with some type of border fencing. They only have enough money to buy 18 feet of fencing. What dimensions should they make their garden, excuse me, in order to maximize the amount of gardening space? Okay, so the first thing we want to look for is what are they asking us to find? Now, if I reread this, they're looking for dimensions. They want to know how big they can make their garden, but because they want their garden to be the biggest possible area, they want to maximize their gardening space. So we're looking for the dimensions that give us the biggest area. Now there's going to be a lot of dimensions we could use, but they won't give us the maximum area. All right, so in order to do this, first thing I want to do is I want to get a visual. I want to get a picture. So I'm going to go over here and draw a house. So here's my house. And remember, it's against the back wall. Okay, so this is the back side of the house. Here's the wall. And this is going to be my garden area right here. Love the pictures because now I can get an idea of what I'm looking at. Okay, so looking at my gardening area, I'm going to say, okay, I have 18 feet of fencing and I want to use it all to surround three sides. Since it's rectangular and that's the shape I'm using, I'm going to say, okay, this could be a width. I don't know what it is yet, but I'm looking for the dimensions, and this would be a width and this would be a length. All right, so we're going to recall some of our old formulas. And the first one I'm going to use perimeter. Okay, I want to put a fence around the perimeter, and we know perimeter is the sum of the sides. So in this case, my perimeter would equal W plus W plus L, the length. And remember, the other length is the side of the house, and that's covered for, so we don't need to worry about it. I'm going to rewrite this because I have two like terms to 2W plus L. So that's the perimeter of our garden that we're going to build. Okay, we know we have 18 feet of fencing, so my 2W's plus L must equal that. So I'm going to go ahead and make a formula. I'm going to say this is going to be 18. That's my perimeter. Sorry, I'm going to erase that. And instead, I'm going to write it underneath. So perimeter, this is still perimeter, has now become 18 because that's the length of our fence we have. That 18 must equal 2 widths plus 1 length. Okay, the second part of our problem wants to maximize the area. So, because we can't really figure out a width and a length from this, because there's multiples, we need to find the right width and the right length that maximize the area. We need to bring in our area function. So we know from geometry, the area is length times width. Okay, so this is a system in some sort. So what we're going to do is we're going to find the area or the maximum area using a graph. In order to graph it, we need to get it down to one variable. I have an L and a W. So what I'm going to do is the information over in the perimeter, I'm going to rewrite it and solve for one of the variables. L looks like a good one to solve for. So I'm simply going to go minus 2W minus 2W and get 18 minus 2w is equal to L. Okay, I rewrote L in terms of W, and that's how we pronounce it. One more time. I rewrote L in terms of W. And what I can do, draw a little line, I can come to my area and say L, which is now 18 minus 2W times W. Now my area is in terms of just simply W, and with some quick simplification, I can say this is 18W minus 2W squared using the distributive property. And with a simple rewrite, I get negative 2W squared plus 18W. And this is my area function. So again, to recap what I did, I used the perimeter. Remember, 3 sides. I used the fact I only had 18 feet of fencing, so my perimeter can only be 18 feet total. I pulled out the area because we're looking for the maximum area, so the area formula. Rewrote it in one variable using the perimeter. So I solved for L in this case. You guys could have solved for W as well. It'd be the same thing. I solved for L, rewrote L in terms of W, substituted it in my area, simplified, and I came out with this area function. Okay, the next step. I know, and this is what I'm thinking, that when negative 2W squared plus 18W is a parabola, because it's squared is a degree of 2, and is upside down. So this is essentially going to look like this, where this being area and this being W. Now the maximum is going to be at the vertex. That's going to be your max. So in order to solve our problem, we need to find the vertex. Okay, a number of ways to do the vertex. Now really listen to this part. You have standard form, you have intercept form, you have vertex form. All three you can get to the vertex. You're going to have to choose one more time. You can choose one of the forms to find the vertex. Standard form would be easy, negative b over 2a. Substitute it back in. Intercept form, this is easily factored. You could split the difference. I'm going to go ahead and use vertex form because I want to just point at it. I can say my vertex is h and k. So again, it's up to you, your choice. I'm going to choose vertex form. Okay, here we go, vertex form. Means I have to complete the square. So the first thing I notice is I have no constant term. There's no constant term to push over. It's already done for us. So push over the constant, not there. Pull out the leading coefficient. Remember, not the GCF, the leading coefficient. So it's a negative 2. Don't take a W. Plus sign, we're pulling out a negative. That switches to a minus sign. And leave space for our new term. Okay, we're going to half the middle term. So half the middle, that's negative 9. Divide that in half, I get negative 9 halves. Square it, that becomes 81 over 4. So I'm going to add 81 over 4. And if I add it, I also have to subtract it. Remember to multiply by the negative 2. Now we're going to factor it. Now remember the term we factor it to is always this guy. So he's going to be minus 9 halves. This side, with quick simplification, we can see a negative and negative is a positive. Some quick cross canceling, that's going to be 81 over 2. We're in vertex form. You can see your vertex at this point. So what we're going to do is, let's extend the page a little bit so we get some more room to write. We are going to rewrite our vertex form. Change colors here. And we're going to put them in decimals because when we're talking about fencing, we don't say 9 halves. We say, what is half of 9? When we say 4.5. 4.5 feet. half of 81 is 40.5. Okay, let's pull the vertex out. Our vertex in this case is H and K. Here's our H, here's our K. So it's 4.5 and 40.5. And if we go back to our picture, the X in this case would be our W. So this is the W we're looking for. This is the width. And the 40.5 is our maximum area. So the maximum area we're going to have is 40.5 square feet. The width that will give us that will be 4.5. The original problem, we're looking for dimensions. Let's go back and look up there. Looking for the dimensions that maximizes. We know the maximum, 40.5 feet, square feet. The dimensions, however, we have to go back and do some substitution. And we're going to use perimeter. We know that 18 is equal to 2W plus L. So with a quick substitution, so I'm going to come back up here, we can say that 18 is equal to, remember our W is 4.5, plus L. With some quick solving and simplifying, we see 2 times 4.5, well, that's just back to 9. So 18 is equal to 9 plus L, or L is equal to simply 9. So our dimensions that make this work are a length of 9 and a width, which we found down there, of 4.5. So if we look back, we can say, okay, if we make our garden 4.5, oops, sorry about that. Let's go to the other side, right it above it. All right, if we make our garden with a width of 4.5 out, so this distance is 4.5, and our length of 9, and this is 4.5, we will have a max area of 40.5. Okay, take notes, make sure you reread them, kind of understand what's going on, each process, and we will work more of these in class. If you have any questions, again, jot them down on the side and I will answer them when I get back.